everybody, today we're going to be talking about solving equations using addition and subtraction. And when you really look at this, I think this is a concept everybody could understand. We've kind of been hinting at this throughout the year, but now we're going to formally understand it. So I'm going to start off by a little conceptual knowledge, a little understanding of what equal is. If I want something to be equal to the other thing, they have to be the same. But in addition to being the same, they need to be the same on both sides. So let's use the idea of a scale. If I have a scale, and on the left side I have 8, on the right side I obviously need to also have 8. If I subtract 2 from the right, I also have to subtract 2 from the left. Okay, now they're still equal. Same thing is true if I add. If I add 2 to the right, I also need to add 2 to the left. So not only are they the same, but they're the same on both sides. So let's look at a couple examples. Example number 1a. If I have x minus 2 equals 6, I want to solve for x. I want to know the answer to x. Now many of these problems you're going to notice you could probably use mental math to figure it out. But I don't want you to do mental math. I want you to know the procedure on how to do algebra because you're going to be using this later on in your math career. Okay, so the goal is to get x by itself. So I'm going to circle x so I know it has to be by itself. I want to get anything else that's on the side with x away. Okay, so I want to get rid of negative 2 or minus 2. So I ask myself, what can I add or subtract to negative 2 to get 0? Well, if you remember back to the theorem of a plus negative a equals 0, it means I can add its opposite. So the opposite of negative 2 is positive 2. So I'm going to add 2 to both sides. X is going to be equal to 8. Negative 2 plus 2 is 0, so I'm left with x is equal to 8. So let's try it again here. I want to get x by itself. I'm left with a negative 7. The opposite integer of negative 7 is positive 7. That's going to allow me to cancel this and make it a 0. Since I added 7 to the right, I also need to add 7 to the left. So I'm left with 25 equals x. And that's our answer. We're not going to flip that around. We're going to leave it as the final answer of 25 equals x. Okay? I'm going to show you a couple on my own problems for you to try on your own to see if you can understand this concept. I would pause it at this time to try this example out. Here's the answers to the on my own question. So as you can see in the first example, I added 3 to both sides. In the second one, I added 10 to both sides. And then the last one, I added 6 to both sides. Let's go on and figure out what happens when I don't have a minus a number. What happens if I have a plus a number? So let's look at these two examples. In the first example, I have x plus 2 equals 9. So I can ask myself, what plus 2 equals 9? I know 7 plus 2 equals 9. But I want to formally and algebraically solve that this is true or prove that this is true. So again, I want to get x by itself. I'm left with a positive 2, a positive integer of 2. So what's the opposite of positive 2? Negative 2. So because I subtracted 2 from the left to make a 0, I'm going to subtract 2 from the right to make it a 7. Okay, so I'm going to use the same strategy in 2b. I want to have x by itself. So 11 is a positive integer. The opposite of positive 11 is going to be negative 11. So cancel it out to get x by itself. Therefore, I'm going to subtract 11 from both sides, and I'm going to get 15 equals x. Here are some on my own problems for you to try. I would pause it at this time to make sure that you have enough time to solve it on your own. Here are the solutions to the on my own problems. As you can see, in all the examples, I subtracted the positive integer from both sides to solve for my variable. Sometimes my variable is on the left, sometimes my variable is on the right. It doesn't matter. Leave it the way it is. Don't flip things around. That pretty much much concludes this lesson. If you have any other questions, feel free to ask me in class, and I will be glad to help you out. Have a great night.